Okay, here is a 3D shape that's a weird one. So we've got a cube, and we have drilled a hole through the middle of it, and we're looking for the surface area of this cube. So far we've looked at some 2D shapes, but here's a 3D one that's weird. So if we just had a cube, the area of that cube is 6 faces that are all the same. So the face of a square is 10 by 10. We could call it base times height, or we could call it length times width, or we could call it one side squared. So in this case, the sides are 10 meters. 6 times 10 times 10 is 600 meters squared. That's the area of the cube, which is good to know. Trying to highlight, which is good to know, but not the end of the story. What we have next is we have drilled a cylinder out of the middle. If we look at the net of a cylinder, I'm going to draw it vertically because that's how I can draw it. A cylinder, if we unwrap it, becomes like this in the net form. We've got a circle here, has an area of pi r squared, a circle there with an area of pi r squared, and a rectangle here with a length that is equal to the circumference of the circle, and a width that is equal to the height. Normally for a cylinder, we say the surface area for that cylinder is 2 circles, that's a circle and there's 2 of them, plus that rectangle, 2 pi r h. But for this circle, we can't stop thinking here, this isn't a surface. We can't touch this. We can't paint this. This is not a surface. It's been drilled out. It's air. So these circles aren't included. So the part we need to add on, so this drill has added a surface on the inside that you could touch inside that cube. We need to add on 2 pi r h, which is 2 times pi times the radius of the circle. If that's the diameter, 5 meters, the radius is going to be 5 over 2, or 2.5 meters. So the radius is 2.5 meters, and the height from here to there is 10 meters. That's one that goes through the whole cube. So we take 2 times pi times 2.5 times 10, and we find that that cylinder, just this part, not the circles, is 157, I'll say 0.08 square meters. And that's another important piece of information to know, because these 2 that I've highlighted in yellow are surfaces that we need to add together. But there is something else, one more step. So not only did we not include these circles in the cylinder because they're not there and we can't touch them, but we have to remember to cut them out of the face of the left and the right side of this cube. That's supposed to say 5. I don't know what happened when I... So we have to cut them out of the face of this cube. So we have to subtract 2 circles. Each circle has an area of pi r squared. So not only do we not add in these 2 circles, but we also have to subtract them from the cube. So 2 times pi times the radius is still 2.5 meters, and we square it. So we take 2.5 and we square it, we multiply it by pi, we multiply by 2, we get 39.27 square meters. So this part here, we need to subtract from the other 2 that I've highlighted in yellow. So we take the area of that cube, we add in the area of the cylinder, but not the top or the bottom of the cylinder, and we subtract the area of 2 little circles. So the area of the big cube was 600. The area of the walls of that cylinder, or the walls of the tunnel, I guess that it is now, are 157.08. And the 2 circles we've removed from the cube are 39.27. So if we take 600 and subtract 157.08 and subtract 39.27, we get 403.65 square meters. So this was a weird one, but you can pretty much expect one like this on your exam coming up. So be prepared.